recording. Okay, feel free to go, Commander.
Okay, so let me first explain. I guess I should introduce myself, or I shouldn't. I would say that my name is Andrew, and on Twitch and on GitHub I'm known as Commander Trashden, and I'm writing Common Lisp as my hobby language. At some point I decided, in about I think 2019, I decided to make a simple fun project for myself. It was going to be a tabletop simulator-like game for a board game called The Royal Game of Ur. I don't know if you ever heard about it. But anyway, I decided to make this game. I spent maybe like 2 days writing some logic for it. And then I discovered, and then I decided to test it and discovered there's an error. After about half an hour debugging, which is not much, but is quite a lot for me in Common Lisp, I realized there was a stupid error. The error was like this. I had, I'm not going to explain about the game, but the error had some, the game has some like plates in it, and they have colors, and colors were represented by keywords in Common Lisp. This is just symbols from a package keyword, so I can say like this, and this is going to be just a symbol from this package, which is not written here. This is like enum. You can consider this an enum thing. It's a constant symbol with a given name. And I had something like this written. I think it was like this. I think it was like board white. I had this instead of having this. Doesn't work anyway. So this is what I wanted to have, and I just made a typo, and this is what I had. Now, it didn't error on me. It didn't tell me anything, but this thing was obviously always nil because the board was a class that I created for my game. And white is this, enum thing, so they're never equal, of course, and Lisp knows that. It knows that they're never equal, and so it was always nil. However, it didn't help. Oh, somebody joined. That's nice. However, it didn't error on me, and the reason why it didn't error is because of this. If I describe this SQL function, as you would see what it does, it takes in any two types, T and T, and returns a Boolean. And it works exactly like this. It tells you if two things are equal or not. Doesn't matter what they are. So this string is not this number, but the number is the number. It doesn't care about types. I realized this is not what I want, and instead what I want is a function that would compare two things with similar types. And if there is no definition for these two types, it would tell me that. And I soon realized there is no such function in Common Lisp, and in fact it's really hard to make one, because the built-in dispatching mechanism doesn't provide any compile time type checking at all. So there are methods, as I've told you already, and they can dispatch, they can have like a function for many different types with the same name, but the problem is it will only be a runtime dispatch. It won't check anything at compile time whatsoever. So I thought, well, maybe there is a library for that already, and I searched the internet and I found a library called Specialization Store. I'm only mentioning it here because, for the history. However, what it also did is that, it kind of did what I want, but in general, what it did is it tried to compile something like this to an efficient implementation. However, if it saw something like this, it would just check if there is an implementation for number and string. Most likely would find out that there isn't one. And then it would just assume that, there isn't one still. However, it might happen that it will appear. So it wouldn't say anything. It would just silently give dispatch to a runtime process. So again, it wouldn't error. And this is not what I wanted. And I tried to talk to the creator of the library and, convince him to make it so that it would error on such things at compile time. And he didn't understand me at all. What he said, I still remember, because what he said was like, why do you want this? Why do you need this feature? Why do you want more errors? And this is something that struck me. I was like, what do you mean? Because this is ridiculous. This code is not working. And the guy asks me why I want more errors. This doesn't make any sense to me. I ended up on Reddit Lisp telling people how I want this thing, and there were like suggestions to go to this static dispatch library. But then there was some guy from India who told me that he understands me and that we could probably try to fork this static dispatch and rewrite it for our needs. And after we tried it a little bit, he said that he doesn't understand the guy's code and instead he will write the dispatch for himself. And this was the start of my project. So basically I wanted to make a small game. And instead, me and that guy started to write a dispatching library, and I started rewriting standard Lisp library in terms of this dispatching library. Okay, now after this introduction, I'm gonna show some examples. So this is where we are today. Let me load it. It's called polymorphic functions. Go in package, polymorphic functions. Case over there. And I'll just define a polymorphic function foo on A and B, and define a polymorphic function foo. I'll remove this, I think it's not needed. On string and string, and a number and number. It has some syntax like this for inline, which is not a standard inline syntax, but you know, number, B, number. Let's say it returns T because it doesn't really matter. It will infer it anyway, and it will just do this. Just in case. Okay, now let me compile this. Our library only works if you compile it with some speed, with like basically not, but in C++ you call this O0, I think. And in here we call it optimized speed. So this means speed is not 0. I think it sets it to 3, but basically it can be overridden by something, but it can never be set to 0 after this. And let me do this thing. Okay, so, and now what about this? Yeah. So ignore this long preview. It's format information, just ignore it. Let's pretend it's not here. This is what it does. It expands into this form, which is the values Boolean optional, which means we enforce the return type to be Boolean. And then it just calls a function that is like inner defined by this thing. See, it doesn't like it because I already defined it. When I compile this, it defines a function inside that is called like this polymorphic functions dot non-user, then this name, because you know this is, I guess, how you can distinguish it. And this function is specialized, and it returns it and puts it here, and then it is the function that is called on these two numbers. Same happens here. This thing that is specialized for strings is then called on these two strings. So the way this is done, because I'm not the author of this polymorph library, I'm not exactly sure, but I think what he does is he just, well, let's see actually, let's just, let's see what it expands into, because we can check it. Make it expand this whole thing. Yeah, there's a lot. Yeah, there's really a lot. This is hard to explain, but let's see. Basically, it does a lot of things inside of the compiler. Yeah, the guy from India who made this library is really smart. Like, I've been told he studies in one of the best universities and he's like one of the best students on his faculty. So yeah, he, for example, he realized how to do how to basically dig into the compiler's intrinsics so that we could also use compiler type inference, at least on SBCL, the main compiler. I still don't know how he did it. He just said he will try to do it, and then in like several hours he was like, yeah, I'm done. Anyway, it does a lot of things here with regard to what it needs to do in the compiler intrinsics, but like in the end, what it does, it sets it here, and I don't see where else it sets it. Number here. And string also must be somewhere. It just registers. Oh, probably after that. No, I don't know where it does it. Anyway, this is where it registers the definition. So it takes this symbol and basically says, okay, so the function definition of the symbol is gonna be this long lambda, or this list named lambda. I don't know. I think he invented the ability to name lambdas with lists. He managed to somehow create a macro that can be used to name lambdas with lists. I don't know how he did it, but it basically registers these functions on all types, and then it just replaces them with compiler macros. I don't know. I think I recall telling you about compiler macros, so I won't stop on this for a long time. But compiler macros are basically hints for the compiler to how to maybe inline function more efficiently, or do some optimizations on the go. So this is what it uses. It uses compiler macros. But however, we also have this is compile time dispatch. We also have runtime dispatch in case something is not known. Let me define this thing. Actually, you know what? Let me just call it, see if it works. Yeah, it works like this. It's fine. And if I call it like this, yeah, it's also fine. Will it work? Will this show us the runtime dispatch? Yeah, so the runtime dispatch is basically we create a huge cond expression here. And we say, okay, so if B is of type string and A is of type string, we call this thing. If B is of type number and A is of type number, we call this thing. And otherwise, we just call this function that calls an error, basically. So that's that. So this is as much as I can explain about his library, because it's really complicated. It's more complicated than mine. It generates these forms and these lambdas and puts them instead of these function names, basically. And then the compiler is good enough to inline them, and then the dispatch happens. So that's what it does. Now about my thing. So I started with just this thing. And I started with defining my favorite equality function, because I really wanted to. So the equality in Common Lisp works like this. It can be called on one argument. On 0, it cannot be called, yeah. But on one argument, it always returns true, and then it can be called on an arbitrary number of arguments, and it will just, compare all of them. If at least one is not equal, it will return nil. So while I was creating this, I was basically testing his library, and we found a lot of errors there. And this is how his library doesn't even need tests. He just loads my stuff. So I'm basically a tester for him. So at first I created something simple like equality, non-equality, and then I went to So something more complicated, like I think I have here plus, I have this, more or less, and more or equal, and less or equal, and then plus minus, division, multiplication, min and max as well. One of the problems I found out is that, so I saw somebody on Twitter at some point mentioning that, how it's cool that people are saying that how cool is that Haskell can manipulate types as data, and then there's Common Lisp that just does it as well, normally, without even mentioning. And this is true and false at the same time. So on one hand, yes, in Common Lisp you can manipulate types because types are just lists of symbols. So for example, this, or rather, let me just say it like this. This is a type. If I have a function, let me actually restart the repo, just so it will be easier. If I have a function, see, I'm bad at names, so I have to restart the repo to not clobber the namespace with the same name. I can declare a type of a thing like this. And it will work. As you can see, it does something simple because it understands this is a simple array. So the type is just this thing. So this sounds cool. However, the problem is that you can't really work with this thing because this is just a list with an arbitrary name here and then an arbitrary name here and then something here. If it was something more, structured, like a class, for example, it would be better because then you would say, okay, from this class, which is a type, class for a type, extract me, extract me a type of element, extract me the dimensions, extract me the simplicity of the array, if it's simple or if it's a vector, because in Lisp it's kind of muddy, array is any array, and then there's a vector, which is also an array, but not a simple array, and then there's a simple array, which is an actual array. So it would be better if these were classes. So then there would be no problem with names. So we had to invent a specific macro called with type info here that can properly extract this kind of useful info from the name type. We also needed a library that could do type inference. This is something that some other guy from Bulgaria did. It's called CL form types. It does primitive code walking and, it does some type inference. It's not as good as, it's not Hindley-Miller or anything like that. It just does code walking and, extracts types from the functions and then tries to merge them with and or predicates, and then SBCL does the rest and manages somehow to create a proper type. So it's some type inference. Common Lisp is kind of complicated in that regard, and it's hard to do full type inference. I'm not even sure if Hindley-Miller is really feasible here. I don't know, but combined with the compiler type inference, if somebody is using our polymorphs, it will be about as powerful as Hindley-Miller. So it will be enough. Because it will just, it will properly infer most of the types most of the time. So we had to create this macro and we used it. And then I had to come up with these monstrosities because of the absence of type inference. So for example, this is what I did for array, right? So what do you want for equality for array? You want to compare the total size. Then you want to make sure the dimensions are the same. And, lastly, you want to just go in a row measure order, for example, and compare all the elements. But this wouldn't work all the time because it wouldn't inline this thing here, because it wouldn't know, because this row measure thing doesn't always return doesn't properly return doesn't properly explain the return type of itself. It is not really typed. So I had to create a compiler macro for it, where I use this with type info macro, and then I basically have to manually inline this function, create this dimension check, which I think, yeah, is just this form, and this is fine. And then I had to do this. So I had to surround this row measures calls with the form, which would have the element type of the arrays that I calculate here. So for each function where I needed to recursively call it or recursively call any of my polymorphs, I had to manually inline it and surround all the calls of standard CL functions with something like this. Does that make sense, by the way? Do I make sense? Is it, understandable what I'm saying?
I think yes. As far as I can
Okay,
tell,
cool.
what you did was you were getting around the problem of adding some sort of static type checking to the equality of arrays.
Yeah. Not just arrays,
Yeah,
but
with
any
polymorphism, right?
parametric. Yeah, any parametric type wouldn't work like this. I
Yes.
would have to do this.
Yeah, anyone that is using the row major aref stuff, you are surrounding, inlining it by hand, basically.
Yeah. So I did this anyway, and it was good in a sense. We managed to test his compiler macro, because you can see his polymorphs also have this def polymorph compiler macro form, and it was buggy at first, so we had to test it as well. Yeah, so these are the comments I haven't deleted still. Gotta look at this and clean it up. There's just so much work here, I'm getting lost at it. Anyway, so this was simple. Then I went to do the access, which I recently redid. Access was just add, and I had some problems with designing it. Add is just access by index or by key. So the way I initially did it was very long. Let me show it how it was. Please, Emacs, work on me. Quotes polymorph access. Yeah, so the way I initially did it was this. So right now it works like this. There is function add, which works like this. And if the index is out of bounds, it will error. And there's function add safe, which works the same way. However, it returns an optional in the form of two values. First being, the actual value or nil, and the second being the flag if it's a proper return. So here it's a proper index, and here it's improper. But initially I did it like this. It was like add, then this, then it was index, and then it was flag error t. But this caused multiple problems in multiple places, which I'm not going to expand on right now. But and it was also long, and I decided to drop it and just have two functions because it's easier and makes more sense. So it was also simple, and this has some other functions similar to this. So this has row majorette is probably deprecated. I'll probably drop it. But there is also back safe, and front safe, as well as as you can see, I have to manually inline them as well for arrays, because those are parameterized types. So you have to manually inline them and surround them with the with the declaration for element type. And then there is this MTP, what else? Size and capacity. That's it basically. This was also simple. And there was something else that was simple. I think it was copy cast. It does deep copy, it does cast, which is not finished yet because I'm still not decided on how to do proper representation of types. See again, the problem is that there is function coerce built in, and it can, coerce to float or something like this. But the problem is here you have to put a type representation, and in general you would expect it to be a list, or at least this is something that's possible. It doesn't have to be symbol, it can be a list, because types can be represented not just as symbols but as a list, as I already mentioned. And so you cannot dispatch on lists, because on symbols you can dispatch like this. There is a type of just one object. We can check if a thing is of type of this one object. Oops. Yeah, gotta say it like this, I think. Yes. It's not of type of, any other object. And there are also enums, which are just, multiple objects. But the problem is the comparison here happens to be done by this operator equal, which cannot compare anything, any containers. It can only compare primitives. It can compare numbers and characters and symbols, but it cannot compare lists. So there is no, you cannot say that something like this, you cannot say that it is of type this, because these two lists are not equal in a sense that equal understands. Equal defaults to just pointer equality for containers, and these are two separately allocated lists. So this type doesn't understand any containers. So I cannot dispatch on lists. So the cast is a bit tricky here, because in cast I cannot declare a type of just this thing, and then So for example, here for number, I just said, okay, so cast object of type number to a type of member, basically any of this, any of the numbers is just, whatever SBCL do the thing for me. But then I realized that if I have something more complicated, for example, if I want to cast, say, an array into another type of array. So if I want to cast an array of floats to array of ints, I could produce a new array where all the floats are just casted to ints, basically truncated, right? But I cannot represent it here because I cannot represent a type. Oh, somebody else joined. That's nice. Anyway, I cannot represent this type properly in dispatch with this thing. So I dropped it for now. I'm thinking about how to do it. So the main thing here is just deep copy and shallow copy functions. So this was easy. And then I created some macros here as well, just so it will be easier to work with this library. So the main macro is this bind macro, which is huge. Bind star and also bind. What they do basically is they allow you to they allow you to do this, something like this, which is combined let and multiple value bind. So in Lisp you can do this, right? You can declare variables like this and then print them. But if you have a function that returns two values, then to capture both of them at the same time, you need to use this form, multiple value bind, do this, and this is so long and frustrating, and it doesn't allow you to work with let. You have to nest this inside of a let. And also, if you want to declare types, you have to write something like declare type, some type name, and then variable after each let for each variable. So this is very long. And instead, I created this monstrosity, which just expands into. Let me actually load it and show you. Morph macros. So this thing expands into, well, okay, do just the first level macro expand because we don't need this multiple value call. Oh, it will be still there. Never mind. Anyway, this basically expands into what multiple value bind expands. It just creates this lambda, declares all the types inside, and then just calls it with a body here on all these values. This is the same as, as with multiple value bind. Yeah, this is where I took it. Yeah, this is the same what it does. Except it declares the types and it allows me to nest, all these declarations here. Not nest them, but just like use them all here at once. So it's more convenient. It also allows me to declare types in line, which is great. And it allows me to do something like this, for example. As you can see, I said there's an y that is going to be a string, but I didn't specify the type, the value. And it assumes something about strings and creates this, where is it? This thing here, which is what I consider to be a default string. So created a function default as well that is, if you know Rust, you probably know they have a trait default, which is implemented for most of the types, and it just kind of creates the default value for them. So I did that as well. So this was like half of my journey, I guess. Yeah, there is a couple more useful macros here. This is just development area. But then I realized that this was, just minor details. I wanted more, of course. Oh, and there is this Polymorphic STL library, which just exports all the working components at the moment. I decided to create a huge one, two huge ones, called Traversable. And Traversable was supposed to do most of the, traversing functions from the standard. So there are some that are like find, count, remove if not, find if, count if, and even count if not, and find if not. And then there's map and reduce and such. And I started doing those. And there was a problem. The problem was this. So the way you do it in Haskell usually is that if you want to map over two sequences, you just zip them together and then map over this, pairs. And since Haskell does stream fusion and is lazy, what happens is that while you zip them and you allocate these pairs, since in your function you probably don't need, the pair itself. If you need it, of course, then it's fine, but you probably don't need the pair itself. You just need two values. And so it just kind of instantly, you would instantly pattern match against this pair. And Haskell is smart enough to understand that since you instantly pattern match against this pair, you don't need a pair if you don't use it. And it will just not allocate the pair at all. So in Haskell, you zip two sequences and map only takes one sequence and it's fine, it works. Nekoma Lisp doesn't have this kind of optimization. If I were to, cons zip two sequences, it would always allocate these conses. Instead, what they did in Common Lisp is that map, as you can see here at the bottom, takes the result type, so we can, explain what to map to, a function, and then just arbitrary number of sequences. So it can take, let me actually just use this variadic function class. And then it can take as many as you want. And this is cool and all. But the problem was that I tried to be at the same time, I tried to be like compatible with the standard library so that people could use my thing as just a drop in, so that they, don't have to rewrite something just because I wanted to change the design, right? So I wanted it to be like, a seamless replacement. But also I wanted it to be efficient so that if they replaced the thing, it wouldn't result in an overhead. So I wanted to expand into a proper loop. Let me find it here. Count. I don't think I even did the map because I was stuck on it. Yeah, so I did reduce. Yeah, there is still my old comment. This turned out to be way harder than I thought. It needs iterators for runtime implementation. So what do you do? Like, this is the problem. How do you think you do when you have this? Because in Common Lisp you can create variadic functions like this, right? You have this rest arguments, and it puts them in a list of arguments, all these arguments here. How do I map over this list of sequences? There's no way. There's no way to write a loop that would map at the same time over a list of unknown lengths of sequences.
I don't know if I got the problem. Can you go back?
Huh?
Can you go back? I don't know if I got the problem.
Sure. So basically, let me illustrate it here. Actually, why not? So I would do it like this, right? I would have a map, and then it would still have a result type, same as the standard map. It would have a function, and then it would have like container and rest containers. And now what? So if it had a fixed number of containers, for example, let's say I only want to be able to map over one container, over two containers. Let's say I would only map over container one, container two. Then I could say, okay, so this would be, this would have type annotation. So let's say it would be a list, and please parinfer. Man, this thing is written in Rust and it doesn't behave properly. And this would be a list as well, for example. I would have to write it for all combinations, but still. So, yeah, we would say, okay, so this returns T because I will deal with it in the what's it called? In the compiler macro for this function. But anyway, oops, I had to say diff polymorph. Yeah. So I would do just this. I would do loop for, A in container 1, for B in container 2. Do, call function AB or something like this, and then we'd have to, let, result, somehow make result. This would have to be, there needs to be some sort of function here as well that just produces a result container out of this result type here. But let's say we have it. It's possible. It's possible to do, make a result container. And then we would have to somehow do just, push, let's say push back and then this res, and then this thing. And then in the end we return res. So this is a naive implementation. The problem is if there is an arbitrary number of containers, I cannot do this. I cannot do these lines here because I don't know how many lines I need to write. And there's just this list of containers. So what you do, and this is in fact impossible, there is no way to do it. What you have to do is you need iterators. Iterators, then you can create a list of iterators for a list of containers, and then you can advance all the iterators in a list by repeatedly calling, by mapping next over them. And they would produce a list of values, and then you can apply this function to a list of values, and then collect it into result. So this is how you need I didn't like it because I wanted it to be always, compile time dispatch. But at the same time, I know that people don't always, I didn't want people to have to always declare types. And if it cannot infer types at some point for some reason, I didn't want it to just break. So I needed runtime implementation as well. And I realized I needed iterators. This is where I was stuck for quite a long time because I was, not sure how to do iterators. And at some point, some other guy tried to do them, but I didn't like his implementation as well. I tried first to do iterators the way they're done in C++, but then after some considerations and thinking, I decided to do them the way they are done in Rust. In Rust, as you maybe know, they are done like this. They just have, basically what you need for an iterator is type of element inside, and then method next, which returns an element at the moment where iterator is, and then advances once. And this is how they do it. They only have this next method. I'll continue from here, but let me first show you the second big thing I wanted to do. The second big thing I wanted to do is data structures, because in my perspective, Common Lisp really likes data structures. So what it has this, single linked lists like this, which are nice, but they are untyped. They are always, polytyped, or how do I say it? Anyway, they're not parametric. It has vectors, which are fine and parametric. And it has hash tables, which are not parametric as well. So they're also untyped, always. They have just this magic 6-hash function that just can hash anything. I don't know how it does it. I still have no idea. It just can hash stuff.
Commander, just a second. Nathan dropped a question that I think I shared.
Yeah, sure.
Do you know how they command how the iterators end?
Yeah. So, I know. I'll explain it. I'll explain when I get to iterators. I think we still have like 20 minutes, so it will be possible to get there. But basically, let me actually see. There is a chat here, right? So I can. How do you know iterators ended? Yeah, so the next method returns an optional. I should have said it. It returns optional, basically maybe. And when it's none, that means it stopped. In my case, I made it so iterator returns 2 values as well, so I mimic the optional. And the first value is either the thing or nil, and second is the flag true or nil. Yeah, go strategy, yes. So returning 2 values is basically unboxed optional. So naturally, I could have made the optionals, but I know that again, in Rust and in Haskell, the main optimization that they did for this specifically is that they don't allocate the structure for an optional if you instantly disband it, dispatch it. And the Common Lisp just doesn't do it, and I didn't want to clobber because it's a garbage collected language, it would be instantly filled with these optional structures that I created just so, it could be type safe. So 2 values make way more sense to me. Sorry, I didn't look at the chat, and I see Breno posted this game of Ur. Yes, this is exactly the game that I had in mind when I started. So anyway, I also wanted to add, first of all, hash sets, just maps, so red-black trees, and sets based on red-black trees as well. So maps and sets on red-black trees. But later I realized that if I want to do efficient iterators, so for example, I could do iterator for a vector because it's easy. You just have a structure that has a reference to a vector and an index. Done. And I could do iterator for list here because it's even easier. You just have a structure that has a list head, the current head. It looks, and then with the next it just switches to the CDR and returns car. That's it. But I couldn't make an iterator for a hash table because I don't have an access to, insides of a hash table. I mean, I have on SBCL, I think. On SBCL, it's easy to see. We just go simple. Oh, not this, I think. This macro expand all, and then we call this horrible thing that I can never memorize. Let me see how it's done. See, I can never memorize something about common Lisp. That's saying a lot, right, about the design here. So how do we loop over a hash table? Oh yeah, sure. This is how we, for example, print the whole hash table. For k being the hash keys in hash table using hash value v, to and then the format. So if we expand it, it expands into this huge thing. What's important here is, let me find it. Oh yeah, I think it's data vector ref. Oh yeah, no, it's this. It's hash table pairs, this function. So if I create a hash table, make hash table, and then even fill it with something. Hash with 1, let's say 1 would be, A, and then 2 would be B, and then 3 would be C. And then I call this on this hash table. It's gonna give me its insides, which is this, it uses open address, and I don't know, so if you know what open addressing is, there are at least two types of hash table. At least I know two types. There is this thing with the buckets where you have a vector and then you have lists in each slot of the vector, and then these lists are like buckets, and you put elements with collisions in the lists, and then when you are, trying to find an element, you first walk over the vector, you find the place by the hash, and then you just walk the list linearly. And then there is this open addressing thing which doesn't use the buckets and instead just uses a longer vector. And when you're trying to put an element somewhere, you basically have to you put keys and values in the same vector. And to find an element, I think you walk the vector with a certain step that becomes smaller and smaller until you find it. Something like this. I have to reread Corman to remember how exactly it's done. I have to do it because I need to implement this hash table still. So as you can see this vector here, but I cannot use it because on other implementations it would be different. So I don't know, and I'm not ready to do this on all implementations. I cannot figure out, how they do it on every implementation. It's gonna be like a hell of a code. So I decided to make my own hash table as well. Then I decided to add a ring buffer. And then I decided, what the hell, since I'm doing this, I might as well add a single linked list, double linked list, so basically everything. And then I decided to make my own vector as well because it's probably going to be faster. it is actually faster than the built-in one, because built-in one has so many features that it needs to support, and mine is going to be just simple, vector that can be extended and then, can be shrinked as well. So that's it, nothing fancy. And then I needed to, how many time do I have? I think I have 15 minutes or even 20 minutes, so that's fine. I needed to somehow make them parametric. And this is the big thing we're working on right now, because I have my old idea. Let me demonstrate it on something like a ring buffer. So my old idea was to do C++ like templates. This is what I came up with at some point. So the way it's done is the way it's done, maybe the ring buffer is not the best thing. Let me see, is double linked list better? No, I think it's the same. It's the same ugly thing. So ring buffer is better. So the way it's done is basically this. I create a structure with this custom def macro that I have, and it has, it is untyped. As you can see, for ring buffer, the data is simple array of t, so it's not specified. However, then I create a macro that is actually, let me think. What is the best approach that I did before and I did after that? Never mind, I'll explain this one. I have a macro defined link buffer that defines a structure, empty structure, that is inherited from this thing here. And why do I do this? Because it has a custom name, basically a code name. I have several hash tables here. Okay, not here. I think it's somewhere. I think it's here. Yeah, I have several hash tables here that I use to map the list names, so the names of actual types, to these code names. So, for example, here, let me load it as well and use it to demonstrate something. Data. So if I say ring buffer of type fixed num, it creates some ring buffer. And now if we look in this unparameterized name, by the way, it's made with a typo. It has this mapping, so there's this key for ring buffer of fixed num, and it's called ring buffer 1 here. And there is also this general ring buffer of type T, which is called ring buffer 2. And there is a table that maps in the reverse order. So we did this. And now we also need a type, ring buffer of general type, which basically has to kinda do this. If the name of the element inside is not given, in Common Lisp it defaults to a star then it's just this thing, the default one. However, if it's given, we go here, we check if it already exists, this ring buffer and name in this hash table. If it doesn't, we call this macro to ensure that it exists in the type declaration. We call this macro in the type declaration. And then we just return this actual name of the structure that we defined here. So I had to create this fake empty structures to map actual list names to the code names and then create them instead. So for example, you can see how when I created this ring buffer fixed num, it's actually it's called here ring buffer 1. So it's a structure of type ring buffer 1. Then I have this function that just uses a val to evaluate this definition in place. And then whenever I create a ring buffer like this, I check if it exists in the table, and then if it doesn't, I ensure its existence, and then I create it like I just call the built-in function, make ring buffer 1 or something like this, with the size and the data. So this is how it extracts, this is how it becomes sort of kind of type. So C++ templates do the same, well, they do similar thing. If you ever look at the way C++ disassembly works with some template code, you will see that it gives this ridiculous long names to its functions. And this is what it does. It does the same thing. It gives them like code names. Because it doesn't have any really, parametric like structures. It just gives them code names and defines for each parameter, it defines its own structure. So this is what I do here, basically. And then, we just define all these polymorphs on the ring buffer. And I had to go and, for example, here, if I want to define a function front on it, I can define it like this, but I want to return a proper type. And since I don't have the access to the type of element inside, I have to write this compiler macro and explain to it how to get to this return type. So I use the CL form types to extract the type of the buffer, the actual type, this ring buffer 1 thing. And then I say, okay, let element type, and then I extract it from the corresponding name in the hash table, and then I inline it manually. It's pretty similar to how I did with arrays. And so I had to write all the functions like this here. And there's a lot, as you can see. And this is my old approach. Wow, what is this? This is long. Oh, this is add. I have to redo add here. Oh my god, yeah, this is old add. With this error policy, the way I did it before. This thing, I had had it like this, and I had to supply this flag. I have to redo it. Actually, good point. Let me at least fix me redo to add safe variant. Gotta keep this in mind. This library is becoming too huge for me solo, Yeah, anyway, so, but now we have a probably better solution, and this is what I intend to use for my iterator protocol. So better solution is basically the way something this Indian friend of mine came up with. It's called extensible compound types, and it's basically a new type system for Common Lisp. It's not connected to built-in type system. It's a completely new thing that just kind of plays nicely with the built-in type system, but also adds the ability to do polymorphic types properly. I don't fully understand how it works. This is why I wasn't able to extend it in the last 2 weeks. I tried, but I failed. So I'm basically waiting for him to do it instead of me. Could dynamic dispatch solve the same issue? Going back to the equality problem. I'll answer this question after I'm finished, okay? So let me go here. Iterators new. So as you can see, I already started doing iterators like this in the old way. And while doing iterators, I basically started looking at Rust a lot and looking how they do things. So this new iterator protocol is inspired by Rust hugely. It's going to have like lazy map, as you can see, and it's going to have all the functions. You can basically open something like Rust iterators, iter in std, and look at how they did things. And this is exactly what I'm going to do as well, because I really like their iterator protocol. I don't like everything in Rust, but their iterator protocol is just great. So yeah, so I'm waiting for this X type thing to exist, and the way it works is basically Common Lisp allows you to define your own declarations, which start with declare, and it would go like this. You then can, declare X type of objects to be something, and it will, just somehow understand. I think it allows you to, you can explain. I'm not sure. I only tried to do it once, and I think I understand how it worked, but it was like a year ago. You can enrich the lexical environment with some information about variable. You can basically add information, custom any information about variable to a lexical environment, and it will get passed on. So you can just pass around this custom information about variables and functions as well, and this is how you can basically make a new type system, because then you can extract this information from lexical environment, and you can manipulate this information. This is enough. Basically, this is enough to create a new type system in a sense of compile time type checking. It's not enough to, create actual, types for actual values. So, for example, I don't know, compiler represents numbers like this one. Let me show you. It represents them like this. So as you can see, it returns 2 here. Why? Because fixed nums, that is to say fixed size integers, are tagged in the assembler with 0. So it's basically a type tag. So it can distinguish them from something else. So this is why it turns into 2 in the assembler, because it's like 1 and then 0 for a tag. So this is something you cannot do with this. But in terms of compile time type checking, you can implement this custom type system, and then you just have to make sure it turns into a proper Common Lisp type declarations at runtime, so nothing is screwed. So I'm waiting for this, and the reason I'm waiting for this is because it's much nicer and it has a much nicer syntax. Let me see if I have an example here. I don't. I don't have it. It's not a problem. Let me just copy paste it. Extensible compound type. So the way it looks right now is something like this. Let me actually just copy paste everything, because I don't wanna compile it. I don't wanna compile it and show. This is how it looks. One second. Yeah, I think I want to copy this part. So it looks like this. You can just define specializable pair, for example, specializable struct pair, AB. And then, as you can see here, we say, okay, let's disassemble this lambda that just adds the standard accessor that is defined by Common Lisp itself on this object O. And we want to add this to A and B things. And as you can see, the disassemble will call the generic plus. However, if we and the X type is declared here, pair fixed, not fixed. But if we use our definition, our like the accessors that we defined ourselves, this is what I want to say. Slot A and slot B is how he called them. I want to ask him to remove this slot thing. and just call them A and B. It will not do this. It will just do usual addition. And the reason it's so long is because it assumes they might overflow, and so it allocates a big num. It says, we can allocate big num. But if we force it to also return fixed num, it will be just one instruction. Same goes for single float. As you can see, if we add single floats, it will just, do a proper instructions for adding single floats. So this is much nicer and requires much less syntax. And what's most important, if we do this, it will mean that I am no longer required to write all these horrible compiler macros for all these types, because the type inference will finally work properly, and I would just have to write functions here, for example. And these functions, they will just infer the types properly, and there will be no need for me to explain what types are returned and so on and so forth. Maybe, from time to time I will still have to do it, but usually it will be properly inferred, by itself. So this is what I'm waiting for. The last thing I wanted to touch on before I start answering questions is that I was really struggling for the last month. I was trying to think about how to do these iterators. And especially since, for example, Rust has this both, value and reference semantics, or I would rather have to say, move and reference semantics, but still it has two semantics. You can, address objects by value or by reference. So if you have an iterator on a place and it returns you something, you can then use this, you can use this reference to change a thing in place, because you have an iterator to it. In Common Lisp, you don't have pointers or references. Everything is by value, except most values are references. So, Vinicus left. Well, thank you for coming anyway. You can, always watch the ending on YouTube, I assume, right? It will be on YouTube. Anyway, so everything is by value, except most values are references. So, for example, vectors are passed in by the reference, by copy of the reference. So you can mutate insides of a vector. I think I touched on it, but you cannot mutate the vector itself. So if I return, if I say have a function that tries to find an element in a container, it returns an iterator to that container. I need to somehow be able to, I want to somehow be able to change this element using this iterator. And so my iterators on containers will also have val function and set val function that will be used to change their value in place. So this will be something that is more efficient than the way it's done in Common Lisp, where you can usually see something like this idiom, if I manage to. So, for example, you can usually see something like this, or get hash key table, or set get hash key table something. So this checks if the key is in the table, and if it is not, then it sets it to something. And if it is, then it just returns it. But this has to go to the table twice, because this is the first time, and then when it sets, it has to use the put hash to go inside the second time. With iterators, you don't have to do this. You can just go in once, save the iterator, and then set the place using the iterator. So that's nice. This is why iterators are nice. And then after I'm done with iterators, I can finally get back to traversable and finish these functions here, finish this map here. And then after I'm done with that, I have to finish my data structures as well. And after I'm done with that, I think I can say I have a version 1.0 of my library. So, there's a lot of work to be done here. I'm looking for people to help me, by the way. I looked in the Russian Common Lisp chat. I looked on some other places and think I looked on Reddit and on Discord, but there wasn't much feedback there. In Russian Common Lisp chat, there was one guy who said he might help me, but he's a little bit busy right now, so I don't know if he will. Anyway, so if any of you guys want to help, you're welcome, of course, as well. I think I took all of my time and even had 5 minutes overtime. So thanks everybody for listening. I hope it wasn't too messy. And, if you have any questions, I guess it's time to ask them.
I think we can start with Mageta's question about
Sure.
dynamic dispatch solve the same issue.
So again, the thing with dynamic dispatch is that you're talking about the equality problem, right? The initial one, the one that I was, triggered first. So I really wanted to have it for it to error on something like this. So the dynamic dispatch cannot solve this because the dynamic dispatch, the way it is done in Common Lisp, would just say, okay, I'll call something here when it is run. But right now it's fine.
I see.
I wanted it to error when I compile it. To tell me that there is that this statement doesn't make any sense. So, this is what I wanted.
I have a question.
Sure.
Okay, so can you show us a simplet of code, like a snippet of code, ideally the same code without using a library and using your library?
Absolutely.
So we can take a look on how it looks, because you're basically adding static typing checking in Lisp. And I would be very interested in seeing how that would look like.
So let me think about what would be the best example here. I think we can go here and see. So macros are nice and add is nice. I think I can do this. So let me just go to, for example, let me just go to STL, actually, to the whole thing, polymorph, STL. There's gonna be a lot of, Buffer doesn't like me. Because I added something.
This was my average experience with Common Lisp.
You should be prepared because eventually we're gonna have to come back to it. So.
Oh yeah, we're gonna go back stronger.
Let me actually make the font smaller because otherwise I can't see. What is it exactly? I just can't see the whole code. Well, I don't need this. So what I really don't like about ASDF, the thing that loads the whole thing, is that its errors when it loads the files are really stupid. It doesn't explain the way what exactly is wrong. Like, for example, here I can see this stack trace, but it doesn't tell me anything at all. It tells me what is broken from the point of view of SBCL, but the important information here, compile file error while compiling polymorph data structures as Arcerian buffer, it doesn't tell me even the line where it's broken. So this is what I don't like.
I get it.
Let me just, because it's gonna be easier, let me just disable it for now. This is what I like about this. People ask me, because I have a huge project called Lisp Polymorph, where I have 1, 2, 3, 4, 5, 6, 7, 8, 9 or 10, anyway, 10 GitHub repositories. And people ask me, why do you do this? They are rather small on their own. And the reason is I can go here and just do this.
Get wrecked, people.
Yes, did.
And now a thing that is broken is no longer broken because I disabled the broken thing. I, guess I also have to disable it here. So, as you can see, now it just loads. Yeah, let me do something in terms of CL and something in terms of my polymorphs. So I'll go here and I think here. Yeah. So let's see something simple. So let's disassemble things and see how they look like on inside. So lambda.
No, not necessarily how they look inside. I like pick this. I don't know, make a Fibonacci function or something like that.
Oh sure.
And then
Fibonacci function.
One Fibonacci is the common Lisp standard vanilla way, and the other Fibonacci is your library of making it.
Okay, so the way Fibonacci.
Another question, by the way.
Yeah, sure. You want to ask it before or after?
No, I'll put on the chat.
Okay. Okay.
You don't have to do it right now. Just maybe share a link later, so that we can just.
No. I just came up with something fun. So the way you could do Fibonacci is something stupid like this. If if n is less than 2, then you just return. Otherwise, you return this. Right? However, with my library, and this will compile, and you can see that it's, well, okay, let's also, declare types, just declare, optimize speed. We say that it returns a fixed num. Well, that's not true. It returns an integer. Fibonacci numbers are rather huge. And that n is of type fixed num, of course, because we don't want anything. Yeah. So now if I disassemble this fib, sorry. What? Oh, I think. 1 second. What if I put it here? Yeah. As you can see, it's something. However, with my library, what you can do is you can do this. Fib, I'll call it fib1. So n will be equal, member 0, 1. This is gonna also return values of member 0, 1 and nothing else. And we'll just say it returns n. And also you can say, okay, fib1 on n, that is just integer. Oh, no, of course, that is just fixed num. Naturally returns values, integer optional. It returns fib n minus 1, fib1, of course, fib1 here and fib1 here, and fib1 n minus 2. Yeah. It doesn't inline it, however, the idea is that if I disassemble lambda and I declare optimize speed here, and I declare that n is a fixed num, fib1 n. Huh? Oh, I'm not in diff package. Sorry. Yeah, this file needs to have in package or something. I'll just put them in the repo because it's easier like this. Yeah. As you can see, it calls this function here. And the thing is, this would, like, how do I put it? If I inline it, it's gonna expand in a huge, let me, what was that? What is that thing? I think it's here, function lambda expression. Let me call it fig1, 10. Yeah, it works properly, so that's fine. And now I'll just call function lambda expression of fig1. Oops. So what it expands into is this. And you can see how this member 101 goes before the check for the fixed num. So if you squint hard enough, this is essentially equivalent to this, because SBCL can transform this check, or rather SBCL can transform this check here into this check here. It's the same thing. For it to check for member 01, it would check if it's just less than 2, because it can do it. And then the rest is just this check for n being the fixed num, but if we declare it as a fixed num, it won't check it. And it will call this fib1 on fixed nums, which is this. So these two things are equivalent. This cont and this if here. So this allows you to do this kind of weird dispatch. It's still going to be slow on something like 30, as you can see, but still, it's nicer, I think, this way. It's cooler. On Fibonacci, it looks stupid, because like, why write this whole thing when you can just say this, right? But on something more complicated, when you need really different behavior for different, for small differences in types, you need different behavior. You can describe them without ifs, and you can extend this behavior. So, for example, the way we said it here is not exactly right. So I'd rather say unsigned byte, 62 here. And I'll define it like this. And what about, now somebody comes in and says, okay, but I want Fibonacci function for, for fixed nums, for negative numbers as well. Okay, sure. You don't have to rewrite everything that I wrote here. You can just add your own implementation, which, as far as I'm concerned, is something like, I think it's signum. Oh no, I think it's like, if n is even, then let me check it.
No, I think no, but this already shows me what I wanted to see.
Yeah. You understand the idea. You can extend it in terms of types indefinitely.
Yeah, that's pretty cool. I think we're out of time, although Magita appears to have a bunch more questions.
Sure, I can answer them after
Yeah, no,
this.
I'm just gonna finish the recording right now. Great presentation, Commander. Pretty interesting
Thank you, everybody,
journey
for coming.
as like you're developing something that seems so huge and you're doing it by yourself.
Yeah.
Which is very, very cool. So that's my final comment. I'm gonna start the recording now.